Okay. Now, this same object which was immersed in the liquid, and we concluded that the apparent weight is 6 Newton. Let me but just show you here that we can rearrange the three forces such that having W apparent equal W real minus upward force, bringing upward force to the other side, to the left side, and the apparent weight to the right side, we have then F upward is equal to the real minus the apparent. In this case, we can calculate the magnitude of the upward force. So 10 in Newton minus 6 in Newton is 4 in Newton. Now we have the magnitude of the three forces, the upward force, the real weight, and the apparent weight. And this formula is required to be memorized. Now, what is the experiment done? The experiment done is the following. Immersing the object in the liquid, some water is going to be displaced outside the flask. So why? Since the block here takes the space of this amount of liquid, so it is moved, or it flows outward of the flask. This water is collected in a beaker in which the mass of the water without the beaker, يعني first we put the beaker empty on the mass balance, we set the balance to 0, then we immerse the solid in the water, allowing some water to flow out until the block is at equilibrium. The mass of the water displaced is 0.4 kilograms. Let us calculate the weight of the displaced liquid. It's the mass times the gravity, 0.4 kilograms times 10 in Newton per kilogram, which is equal to 4 in Newton. Then let us compare the buoyant force calculated and the weight of the displaced liquid. They are equal to each other. So Archimedes says that an object immersed in a liquid is subjected to an upward force whose magnitude is equal to the weight of the displaced liquid. Archimedes said the following principle. Again, Archimedes' principle states that the upward buoyant force that is exerted on a body immersed in a liquid, whether fully or partially immersed, is equal to the weight of the displaced liquid and acts in an upward direction at the center of mass of the immersed part of the solid. So this is the second formula that allows you to calculate the upward Archimedes force. Now, in order to derive the third formula, we have that F upward equal weight of the displaced liquid. And the weight of the displaced liquid is equal to its mass times the gravity. And the mass is equal to the density times volume. According to the formula that we discussed in section 2, it is equal to the density of the liquid times the volume of the displaced liquid times G. However, in this case, since the object is totally immersed in the water, or regardless of that, as much space the block or the immersed part acquires, as much volume of water flows out. So that's why we say that the volume of the displaced liquid is equal to the volume of the immersed part. So instead of V displaced liquid, we can say V of the immersed part of the solid. So the third formula becomes density of the liquid times V immersed of the solid times the gravity. And this formula verifies, instead of second, it is third formula, verifies that the magnitude of the Archimedes upthrust exerted by a liquid depends on what? On the magnitude of the liquid, as we mentioned before.